हे स्टार्ट केल्यानंतर पुन्हा आपण PPTकडे येऊया आणि फुल स्क्रीन, जसं मी मगाशी सांगितलं डुप्लिकेट डिस्प्ले. कंट्रोल L करा. हां, लेझर. आता हे आम्ही नेहमीच सांगतो, पण जसं तुम्ही नवीन आहात, मी मगाशी सांगितलं, तुम्हाला एक्सप्लेन केलं म्हणून कंट्रोल Lनी तुम्ही लेझर यूज करू शकता. आता पुन्हा एकदा मी जे रेकॉर्डिंग ऑन करणार ना, तर तुमचं एक्सप्लेन करा जसं मगाशी केलात ना तुम्ही एक्सप्लेन.
इंट्रोडक्शन सीइंग द कॅमेरा
आणि
विदाउट मूविंग.
त्याच्यानंतर शिकवायला सुरुवात केली तरी चालेल.
आणि मग नेक्स्ट स्लाइड हे डायरेक्ट आपण यानी पुढे मागे करायचं. ओके,
हे दोन मग स्टार्ट करू.
Hello, myself Namrata. Today's topic is biological oxidation. So till now we have just learned that energy currency of the cell is ATP. But under this chapter we will just learn how this ATP molecule are formed in mitochondria.
मॅम तुम्ही ना इकडेच बघून बोला, म्हणजे खाली बघूच नका.
ओके, परत सांगू?
पुन्हा एकदा. हां,
अरे बापरे. Hello, myself Namrata. Today we are going to study the topic biological oxidation. Till now we have learned that energy currency of cell are ATP molecule. But now in this chapter we will learn how these ATPs are synthesized in mitochondria with the help of oxidation of foodstuff. So we will be studying biological oxidation under this headings. So at the end of this topic, we should know what you mean by oxidation, what you mean by reduction, what is redox potential, how high energy compound form in the body, what are the enzymes, coenzymes are required to deal with the electron transport chain, the mechanism of formation of electron transport chain, what do you mean by what do you mean by oxidative phosphorylation and its mechanism, how the ATP is inhibited by different molecules in the body, and finally what do you mean by substrate level phosphorylation.
आता तुम्ही इकडे जे एक्सप्लेन केलात याला पॉइंटिंग केलात का?
नाही ना ते.
हां, मग पुन्हा एकदा त्या स्लाइडला जा.
परत
पुन्हा
घ्यायचं का?
जे तुम्ही वाचताय, जे लर्न करताय, जे तुम्ही शिकवताय ते.
हां, मग हे कंट्रोल पीनी हे करू शकतो ना मी हायलाइट. मग मी खाली बघू शकते ना आता? खाली
बघायचं, पुन्हा शिकवता शिकवता वरती बघू शकता कॅमेराकडे.
ते थोडंसं डिफिकल्ट आहे मला यूज टू असतो. ओके, परत चालू करू?
हो, चालू.
म्हणजे स्टार्टिंगपासून
कंट्रोल L करते, लेझरनी फक्त तुम्ही हे करू शकणार.
म्हणजे इंट्रो पासून की फक्त पॉइंटिंग आउट हे. So at the end of this lecture we should able to know what you mean by oxidation, what you mean by reduction, what you mean by redox potential, and how it forms the high energy compound. We will also study different enzymes, coenzymes, the electron carriers in biological oxidation. Even we will study in detail about electron transport chain. So this electron transport chain is nothing but the oxidative phosphorylation. How it occurs we will study in detail, its inhibitor, and the other way of phosphorylation, that is substrate level phosphorylation, and at the end the shuttle systems. So as I told you, or as I said you, we will be just learning first or brushing up the terminology, what you mean by oxidation. So oxidation, that means addition of oxygen.
मॅम तुम्ही पॉइंटिंग करा ना.
हां.
म्हणजे जेव्हा तुम्ही ऑक्सिडेशन पासून चालू केलात ना, तर तिकडे ऑक्सिडेशनला तुम्ही पॉइंट करा आणि वरती बघा शिकवताना की ऑक्सिडेशन बद्दल तुम्ही शिकवताय.
ओके, ते मला दोन्ही कोऑर्डिनेशन थोडं वेळ लागेल मग. ठीक आहे, मी ट्राय करते ना. So we will just brush up the terminology, what you mean by oxidation. So oxidation is nothing but addition of oxygen or removal of hydrogen molecule, or you can say removal of electron. Exact opposite is nothing
मॅम
but
असं थोडंसं प्रॉपर पॉइंटिंग करा ना, म्हणजे त्या व्हीला आहे ना त्याच्यावर नको करू, त्याच्या खाली करा.
ते कसं दिसतं तुम्हाला? मला इथं तर ते डायरेक्ट त्याच्या खालीच दिसतंय.
हां, त्याच्या खाली करायला.
मग मी पेन वापरू का? इरेज होऊ शकेल ना तो? एक मिनिट,
हो.
मी फक्त शिफ्ट आणि पी ना.
नाही कंट्रोल पी.
Oh, sorry. So we will just brush up what you mean by oxidation, what you mean by reduction. So first we will study what you mean by oxidation. So oxidation is nothing but it's addition of oxygen or removal of hydrogen or removal of electron. Okay, so exact ulta is reduction. So reduction is nothing but removal of oxygen, addition of hydrogen or addition of electron. Okay, for example, ferric chloride is getting oxidized to its ferrous form. So it will accept an electron and it will get reduced itself. So when a compound having both property oxidation as well as reduction, that compound is called as redox couple. Or when an reaction occurring oxidation as well as reduction, then that is called as redox reaction. So now we will study what is redox potential. वेगळी स्लाइड होती. रेडॉक्स पोटेन्शियलच्या नंतरची आहे.
ठीक आहे, चालेल ना. तुम्ही
Okay.
पुन्हा एकदा एक्सप्लेन करा.
So now we will study what you mean by redox couple. So as I explained you, oxidation and reduction, when the substance exit both, that is reduced state as well as oxidized state, then it is called as redox couple. For example, here we are studying the redox couple of NAD. What is the long form of NAD? It is nothing but nicotinamide adenine dinucleotide. So this is getting reduced to form NADH plus H. So the redox couple we can say is NAD, which is getting reduced to NADH plus H plus. So under this chapter we were even studying other reducing equivalent like FAD, that is flavin adenine dinucleotide, which will get reduced to form FADH2. So these are the various redox couple which is simultaneously getting oxidized or reduced. Now we will study what you mean by redox potential. It is nothing but it is a measure of tendency of redox pair to lose or gain electron. That is, just now we have studied what is redox pair, that is NAD is getting reduced to NADH plus H plus. So when a substance has a greater tendency to lose electron, it is called as negative. It is denoted by minus E0. When a substance has a greater tendency to accept electron, then this redox potential is denoted by plus sign. Okay. So always in the electron transport chain, the flow of electron is from more negative to more positive redox pair. That means the molecule will be having more tendency to lose electron, and then some molecule will be having a tendency to accept its electron. Okay, so we have just brushed up about oxidation, reduction, what you mean by a redox couple, and what you mean by a redox potential. Now we will study about what is this high energy compound. So high energy compounds are nothing but the compound which will liberate a large quantity of energy on hydrolysis. So that is called as high energy compound. So energy, how much energy? So that is at least 7 kilocalories per mole at pH 7 is called as high energy compound. And if the energy liberated is less than 7 kilocalories per mole at pH 7, then it is called as low energy compound. So ATP is an example of high energy compound, while that of ADP is an example of low energy compound. That means ATP will release more than 7 kilocalories of energy when it get hydrolyzed, while that of ADP will release 6.6 kilocalories, which is less than 7 kilocalories per mole. So it is come under low energy compound, and as ATP you can see here, it is releasing on hydrolysis 7.3 kilocalories, so it comes under example of high energy compound. So simple way, high energy compound are the compound which release energy more than 7 kilocalories per mole, and the low energy compounds are which release energy less than 7 kilocalories per mole. So ATP is high energy compound and ADP is low energy compound. So now we will study, which we have already studied from our school time.
वन सेकंड मॅम, तुम्ही जे असं कीबोर्डकडे बघून बोलताय ना, ते तसं बोलू नका, म्हणजे
इकडेच राहायला पाहिजे.
बघून बोला, कारण
ओके.
की तिकडे काय करता आणि इकडे मग ते वेगळं दिसतंय थोडं.
बर.
तुम्ही कॅमेऱ्याकडेच बघून बोला. जेव्हा तुम्हाला तिकडे काय करायचं आहे ना कीबोर्डकडे,
हे असं ह्यानी नाही जाऊ शकत का स्क्रीनवरच? हा टच केलं की इन्स्टेड ऑफ हे बटन दाबण्यापेक्षा, कारण म्हणजे मी इतकं यूज टू नाही आहे ना, दोन वेगवेगळे हे यूज करायला लागले तर चालेल ना हे. So now we will just study what is high energy compound and the
आधीची स्लाइड जी तुम्ही आता एक्सप्लेन केलात ना कीबोर्डकडे बघून, तर ती करू शकणार का?
पूर्ण करायची का परत? ठीक आहे,
म्हणजे
पूर्ण तो कन्सेप्ट घेऊ का हाय एनर्जी कंपाऊंड म्हणजे काय तिथून?
हो चालेल, पण तुम्ही आता जे एक्सप्लेन म्हणजे थोडंच केलात ना कीबोर्डकडे एक्सप्लेन करून, तर तुम्हाला जे आठवतं म्हणजे जिथून तुम्ही स्टार्ट केलं
असं कसं? बरं ठीक आहे,
किंवा मग पहिल्यापासून घेतलात तरी काही हरकत नाही, फ्लो मध्ये होऊन जाईल तुमचं एकदम.
So now we will study what you mean by high energy compound. एक मिनिट, याच्या आधी मी सांगितलं होतं वी हॅव जस्ट ब्रश अप द व्हॉट यू मीन बाय ऑक्सिडेशन, व्हॉट यू मीन बाय रिडक्शन, व्हॉट यू मीन बाय रेडॉक्स कपल अँड रेडॉक्स पोटॅन्शियल. त्या 4 स्लाइड्स काय झाल्या ते सांगितलं आणि मग हे घेऊया असं म्हटलं होतं, तरी चालणार आहे का? तसंच कंटिन्यू करू जस्ट?
हो चालेल.
Okay, so now we will study what you mean by high energy compound. So the high energy compounds are nothing but the compounds which liberate large quantity of energy on hydrolysis. How much large? It is around 7 kilocalories per mole at 7 pH. Low energy compound are compound which release or which liberate energy less than 7 kilocalories per mole at pH 7. So ATP acts as a high energy compound, while that of ADP will act as a low energy compound. Okay? So now we will study why this is called as high energy compound and low energy. You can see here ATP is showing 7.3 kilocalories of energy and ADP is showing 6.6 kilocalories of energy on hydrolysis. So ATP is an example of high energy compound and ADP is example of low energy compound. Same way, phosphocreatine, which liberate 10.3 kilocalories of energy, while that of glucose 6-phosphate, which liberate less than 7, that is 5, so it is an example of low energy compound. So now we will study what is this ATP molecule is made up of. So long form of ATP is adenosine triphosphate. The name itself indicating it is containing adenine, it is containing sugar as ribose, and it contains 3-phosphate group. So that's why the name is adenosine tri. Tri means 3-phosphate group, which is acting as a energy currency of cell. So under biological oxidation, we mainly dealing with how this ATP molecules are synthesized in our body. So once this ATP molecule is synthesized from different metabolic pathways, it will be used up for different mechanism in the body. For example, it can be used for biosynthesis of a compound. It can be used for detoxification. D means removal of toxic substance from the body. Then it is also useful for thermogenesis. Thermo means heat. Genesis means formation. So it can be useful for heat production. It is also useful for ion transport, active transport. Useful is it is totally depend upon ATP molecule, and main function, that is it is also helpful for muscle contraction. So this will be synthesized, ATPs will be synthesized in various metabolism, then it will be used up for various activities, and when there is a no need of ATP molecule for any action, it will be stored in muscle and brain in the form of phosphocreatine. So this is one of the favorite Viva question which will be asked, that is high energy compound which will be stored in muscle and brain. So this ATP molecule is stored in muscle and brain in the form of phosphocreatine. So creatine will bind with ATP and then it will form creatine phosphate. So creatine phosphate is nothing but it is an stored form of energy. Whenever our body required, this creatine phosphate will donate that phosphate group to ADP and there will be formation of ATP with the help of enzyme called creatine phosphokinase. बस करायचं की अजून घ्यायचं आहे? मला दाखवा बघू किती झालं बघा.
प्रॉपर 15 सेकंड लेक्चर
नाही झालं अजून आहे. घेऊ ना पुढचं मग. ओके. सो now we will study how these ATPs are synthesized by biological oxidation. So simple word, what do you mean by biological oxidation is oxidation which is taking place in living system. Biological means living system and oxidation will take place, then it is called as biological oxidation. So when we say biological oxidation, oxidation of what is taking place? It is nothing but the oxidation of food stuff which we take through diet. So mainly there are 3 stages of oxidation: first stage, second stage and third stage. So the first stage is nothing but a primary metabolism. That is nothing but when we take a food through mouth, it will come through GIT, where this complex compound like carbohydrate, proteins and lipids will get converted into smaller simpler form. So this simpler form can come into a second stage, that is secondary or intermediary metabolism, where it will be absorbed into the blood, where it will be gone through a common metabolic pathway that is called as TCA cycle, tricarboxylic acid cycle. During this cycle, it will release the reducing equivalent like NADH plus H and FADH2. This reducing equivalent then come into the third stage, that is called as tertiary metabolism or cellular respiration, where it will combine with oxygen to form water molecule, and conversion of this oxygen to water molecule finally will lead to release of energy, which will be trapped in the form of ATP. So we will just study that under this slide in detail. As I told you, there are 3 stages of oxidation: primary, secondary and tertiary. Under primary, which is taking place mainly in the intestine, what happened? The complex food like carbohydrate, lipids and proteins will get converted to its simpler form. Carbohydrate will be broken down to form monosaccharide, lipids will be broken down to form fatty acid, and proteins will be broken down and form amino acids. So this simpler form will then convert it to acetyl CoA or pyruvate, which are the intermediate of TCA cycle. So secondary metabolism is mainly linked with TCA, where this simpler form of all the complex food will get oxidized to form carbon dioxide, and along with the formation of carbon dioxide, it is also form NADH plus H plus and FADH2. So these are nothing but the redox couple, which will be having a property of getting oxidized as well as getting reduced simultaneously. Now this will be carrying the proton along with it, and it will come under tertiary metabolism, which is linked with electron transport chain. So after coming into tertiary metabolism, this will get oxidized to form water molecule, and energy will be trapped in the form of ATP. So now we will study how this phosphorylation takes place in the body. By meaning of word phosphorylation means what? Phospho. ह्याच्यात पण इरेजर आहे का मग? हे इरेज झालं आपलं, चुकून हे दाबलं गेलं तर. Phosphorylation. So phospho means
हा वर्ड पुन्हा हे करता का, इरेज करून?
okay. So now we will study how these ATPs are synthesized in the body. So before synthesis of ATP, we will study a small terminology called phosphorylation. Phospho means phosphate group, which is attached to adenosine diphosphate to form ATP. So there are 2 ways by which ATPs can be synthesized in the body. One is called as oxidative phosphorylation and the second one is called as substrate level phosphorylation. In oxidative phosphorylation, as we have studied just oxidation of foodstuff to form ATP, which is linked with electron transport chain. So around 90% of ATPs in the body are synthesized by oxidative phosphorylation. Very few reactions are there where ATPs are directly synthesized from substrates. So that is called as substrate level phosphorylation. So I'll repeat, there are 2 ways of oxidative of there are two ways of phosphorylation. One is called as,
असं बोलताना तिकडे पॉइंटिंग करा ना.
ह्याच्यावरती का परत होईल म्हणून मग मी इरेज करू का मध्ये? मी जस्ट रिपीट करते.
ठीक आहे चालेल.
सो
इरेज करून पुन्हा एकदा तुम्ही
एक केलं तरी चालेल.
ओके. आणि शक्यतो पेननी म्हणजे खूप जर का तुम्हाला होत असेल तर लेझर यूज केलं तरी चालेल. म्हणजे तुम्हाला
ते लेझर मला तुम्ही अजून यूज टू नाही आहे ना, ते खाली येत नाहीये व्यवस्थित म्हणून मग मी पेन वापरला. म्हणजे मी असं शिकवते नेहमी त्यामुळे. ठीक आहे, बरं
कंटिन्यू करा तुम्ही. फक्त त्याला पॉइंटिंग करा कारण की ते एक्सप्लेन करताना जेव्हा हायलाइट येणार ना त्याच्यावर तर ते व्यवस्थित दिसायला हवं, बाकी काही नाही.
Okay, so I will just repeat. There are two ways by which phosphorylation takes place in the body. One is called as oxidative phosphorylation, where the synthesis of ATP is linked with electron transport chain, and the other way is called as substrate level phosphorylation. That means here ATPs are directly synthesized from substrate, is called as substrate level phosphorylation. I hope you have understand what you mean by substrate level phosphorylation and what you mean by oxidative phosphorylation. So 90% it is synthesis of ATP is by oxidative phosphorylation. So under biological oxidation we mainly focusing on oxidative phosphorylation. घेऊ पुढचं का इथे थांबायचं? बघा तुम्ही आता कसं झालंय.
25
अजून
मिनिटाचं तरी झालं.
हां, मग अजून तुम्हाला काय करेक्शन सांगू वाटतंय ते सांगा. कारण मला अजूनही माझ्या हा लिहिलेल्या ह्याच्यातच मी थोडंसं चेंज करावं म्हणते म्हणून.
म्हणजे लेझर यूज करायचं म्हणताय का?
हां, लेझर किंवा म्हणजे हे जे मी स्लाइड्स बनवलेत आहेत